2024. So we'll be starting our first community meeting in 2024. Since it's still early in the year, I guess a lot of people are on vacation. So you may be watching this through our video stream. So from the next month, February, and for the several months that follows that, we'll have a slightly different format for the community meeting. Basically, we'll have outside speakers. Yeah, so if we'll have people talking about the component model and talking about the exciting things that's happened around the world in the WasmEdge community, from from new plugins, new applications, to things that happen in Japan. So so there'll be a lot more content and a lot more exciting stuff that coming on starting from February. So if you are watching this on video, make sure that you follow us and try to join us. In the next couple of months, I think it'd be more than just us talking. So anyway, so since this is the first community meeting in the new year, so I like to share something that's let me see if I can do this. Yes. Okay, so I shared my screen. I'm at a X page or Twitter page from the WasmEdge's official X account. So here we have our New Year resolution that was published yesterday. Right? So it's so what's WasmEdge was started in 2019. So this is the 5th years. That's time flies. There are lots of things has happened in the Wasm community, and we keep finding new exciting applications. And for a runtime like this, the adoption of the runtime is going to be driven by new applications. It reminds me, say, how did Java come along? It's because of the web application coming along, right? So there's new applications that requires more than just the C++ or Perl or the languages of the day. So and Java filled that hole. That's become a predominant language. How did the Go language come along? It's because of the cloud native paradigm come along, and people need a new language to develop those applications. So Wasm was born in a space where rich browser applications, and also at the time it finds its footing in blockchain applications as well. But in the past couple of years, it has been trying to find its most important application with a niche. So a lot of people, we tried things like serverless or embedded functions and all those. Those are great use cases, but those are not, I think, as big as, say, the web application itself or cloud native movement itself, right? So the biggest movement of the day is really AI and machine learning applications, and it has become very apparent from the last year. So as a New Year resolution, WasmEdge is really to become the portable runtime, the right ones run anywhere runtime for the AI and machine and LLM applications. So in my own words, it's sort of like the Java for GPUs, right? So Java was the right ones run anywhere runtime for CPU applications for all those years ago. But now we not only have more than just a couple of CPUs, a couple of operating systems, we also have a large variety of GPUs and neural accelerators. So we need a new paradigm and new languages and new runtimes in order for developers to write applications on their own development machine, and rest assured that the application is portable and deployable on the cloud, on the edge, on other people's devices. And the traditional containers, like Containerd and Docker, are not portable across CPU or GPUs. They're portable across operating systems, but not across hardware. And the Java itself is not accessible to GPUs as well. And Wasm has a real opportunity to be a player in this space. So that's why our New Year resolution for WasmEdge is to become the right ones run anywhere runtime for AI and LLM applications. We'll focus on this for this entire year and come revisit this statement a year from now, in January 2025. So let's all have that in mind. Well, so for today's community meeting, I think most of the talk would be focused on AI and machine learning, actually, because that's the area that we have been focusing on for the last, I think, 3 months. It's hard to believe, but the Llama 2, the open source large language model, was only released in October last year, so it was only barely 3 months. So we have made a tremendous amount of progress. So we are really, really excited to talk about that. And but before that, I like to kickstart one of the most requested features in WasmEdge in particular, is to support HTTPS. So as you may recall, we have sockets connection support and asynchronous socket, and then HTTP, DNS, and all those support built into WasmEdge. As people start to access other services from WasmEdge, for instance, other microservices or database, and things like that, there's growing need for using HTTPS or TLS connections. About a month ago, we released a new plugin called Rust TLS plugin. That is acting as a WasmEdge plugin that you have to install it with WasmEdge. With that installed, you'll be able to make HTTPS connections from, say, your Hyper application or any Rust application or even JavaScript application. But that requires a plugin that isn't really the ideal way to do it. So in the WasmEdge-quickjs runtime, we have now experimented with a new approach. Let me switch here. So this is the project WasmEdge-quickjs. Just a quick reminder. This is a JavaScript runtime that we have built on top of QuickJS. So we compiled QuickJS into Wasm, and then we developed I think a substantial subset of the Node.js APIs, and have them supported in QuickJS. So from the WasmEdge-quickjs, you will be able to write Node.js-based server applications or web client applications, like using the Fetch API, and then run them as Wasm applications in WasmEdge, right? So with the new HTTP support in QuickJS, we have now completely eliminated the need for an external plugin. So let me show you an example. Here is example.js folder, and you can see there's a bunch of JavaScript programs that we can run with inside WasmEdge with the WasmEdge-quickjs runtime. So here there's an example called HTTPS fetch. So here you can see that it does it can fetch, it can get HTTPS URL, and all this you can build this directly with from your command line and deploy it without any WasmEdge plugin. Just use WasmEdge itself. You will be able to run a program like this. And so going forward, if this proves there's no additional problems, so I would really encourage you guys to try it out. And if this has no other side effects or problems, we intend to move all of other HTTPS support. So for instance, HTTPS support in the Rust hyperquate, HTTPS support in the Rust request quate, have all of them move into move them into inside WasmEdge, and have no external dependency on the plugin itself anymore. So that's something I thought that was very interesting, and that would enable a large category of JavaScript applications that could run on WasmEdge. This is also one of the features when we discussed with community members who's using WasmEdge to run server-side JavaScript. This is perhaps the #1 requested feature. So this is something we have built into our platform, and so yeah. So Well, I think that's it for me now. I'd like to move on to our next subject. So I'll ask DM4 to join in and talk about how to use WasmEdge to run the latest Mixtral MOE models. So I'll stop sharing my screen and pass the control to DM4.
Okay.
All right. Okay. And can you share your screen?
Oh, can you see my screen now?
Yes, I can see your screen. Thanks.
Okay. Hi everyone, I'm DM4 from WasmEdge and second stage. I'm here to show how to run the Mixtral 8x7B models using WasmEdge on the MacBook Pro and 2 Max laptop. And use this repository, second stage Llama utils repository as an example. I'll use these two models. They are both 32 gigabytes. One is Mixtral 8x7B extract model, and one is Dolphin 2.5 Mixtral 8x7B model. Okay, let's get started. And to use the Llama utils, I use the chat example from the Llama utils repository. And since we got two different models, and these two different models have different prompt template format. So here first I'll try the Mixtral 8x7B extra model, and it's the prompt template of this model is Llama 2 thread. So I use this Llama 2 thread as a parameter. Okay, let's go. And the first question I'll try is this. These three most popular books, the information should come to this. You could see since despite I just started WasmEdge, but it says a very short time to load the models. I think it is because the OS cache the model file in the frame. So it start very fast. Yeah. And the next question I'll ask the bot to implement the HTTP API service to return the previous answer. And yeah, the bot is trying to help me to finish the HTTP API server. And you could see the bot create a HTTP API server with two endpoints, the root and the API books. So we can copy this Python script onto an this is the Python code the bot just returned, and I can run this Python script. And you can see it start a localhost HTTP server at port 5000. Oh, yeah. And at the root endpoint, it returned a welcome message. And let's try the API. The API books endpoint return the JSON we just asked the bot to create. And yeah. And now let's try the different Mixtral model. The Dolphin model. The Dolphin model is used the chat ML prompt template format. So I changed these two variable. And now I want the model to help me to implement an HTTP API client to get the API from the previous example and print title and also author field using pretty table. You can see the model is loading into my memory, and once the model is loaded, GPU usage will goes up about 100% to do the inference. Yeah. And now the bot is return the client code of using Python. And it also tell me how to install the dependence package. Let's copy the code. That's the code. Run this code. And you could see that, yeah, the code is correct to query the API endpoint. We're just using the model to help us implement. And yeah, that's it. That's my demo to show how to use the WasmEdge to run the Mixtral 8x7B model using WasmEdge MacBook laptop.
Oh, that's excellent. So, DM4, can you remind us what is the machine you are running on?
It's Apple M2 Max with
M2 Max. Okay.
M2 Max with 64 gigabytes RAM.
Okay. Yeah, that's because the MOE model is fairly large. It has like 7 billion parameter expert models underneath it.
Yeah.
Sorry. Yeah. So I think that's an excellent demo. I ran a demo for the one of the leading internet companies. I wouldn't name which one. They have their own programming framework written in JavaScript. So on the site, it's a lesser known framework, and they just asked the model to come up with a program using their framework, and the model answered perfectly. So the model was really quite capable. Yeah. Anyway, so I think one of the more interesting you can run those models on the Mac laptop with a variety of different softwares. For instance, you can run it with Llama CPP, you can run it with Ollama, you can run it with a lot of other things, or a bunch of other things. But I think the most interesting thing about using WasmEdge is that it brings the true cross-platform experience. So when you run this right application and run this model, the same application gonna be able to run on the server and on, say, an IoT device that has NVIDIA GPU installed. It can run on anywhere that WasmEdge is supported. So it brings the Java experience to large language model developers, right? So it allows you to go cross-platform. So you no longer have the problem where it only works on my machine. My NVIDIA GPU works, your AMD doesn't work. Too bad. That's your problem. So with WasmEdge, we aim to solve this problem, right? But with that, I'll ask Hydai to come along to talk a little bit about our LLM support roadmap. How exactly, where we are with this cross-platform capability, and what we plan to enhance it for throughout the year to bring it to more platforms. Yeah. So, Hydai, please.
Okay, so let me share my screen first. Okay, can you guys see my screen?
Yes, I can. But your voice is a little small.
Oh, sorry. I will try to, say announce. Okay, so we have this issue called inference library support plan, and we welcome anyone if you have any idea about the LLM inference library. Please just leave your comments below this issue, and we would like to hear more voice from you guys. Yeah. So let me summarize. We already support the following backend. And the first tree actually is based on the uh, traditional AI inference part. So we leverage these three backend with the WasmEdge proposal. So you have PyTorch, you have TensorFlow Lite, you have the OpenRhino, okay? And we recently add the Llama.cpp support, so you can run the LLM, say the Llama 2, the Mixtral, just the DM4 demo. And also, this is based on the WASI neural network proposal. So, what's our next support list? And I'm sorry. So we would like to have the following backend support as our new WASI neural network backend. So the first is the Bun.rs, because we believe that this framework is very popular, and we believe it already have the web GPU support in recently. So it's pretty good for us to leverage this, the GPU power on several devices. Because if you are using the Llama.cpp, I can, I can share the release binary for you guys. Go to the GGML, and you will find that if you want to use different backend, let's say they are all Llama.cpp backend. However, if you are on Mac OS, we will use Mantle. If you are on general Linux, you may use the CPU only, or you can enable the Open Blast, or you can enable the CU Blast. However, each one will produce a new and standalone binary, and we have to detect what you have on your hardware. Let's say if you have NVIDIA GPU and you install the CUDA, then we will try to download the CUDA one for you. However, we believe that the web GPU is is a pretty good solution that we can ship only one binary if your hardware is support the web GPU. And we believe lots of the modern GPU already support it. So that's why we would like to put the Burn.is in our the first tier to support. And I believe there are several more popular backend. Let's say the Intel one. This is very good for those who only have the Intel CPU to use. So we believe that our users, most of our users, should have or they are using CPU only devices. Because we receive lots of the report that, hey, could you guys stop, just promoting the GPU one? We only have the CPU machine. So, could WasmEdge provide some, CPU favor backend? and the answer is yes, we would like to, because there is a need there. Okay, so we want to support the Intel extension for transformer, and also because supporting the Whisper.cpp, which is the twins project of the Llama.cpp, and the voice to text application is pretty good, and we would like to have it as our new backend. And we believe this is not a pretty hard job, because that Whisper.cpp is using a very similar project structure, just like Llama.cpp, but some of the details is not synced. Let's say the the GGML format is a little bit different between Llama.cpp and Whisper.cpp. Anyway, this is very detailed one, and we'll just fix it. And there are more backends we would like to try, because that's let's say MLX as as well, because the Apple just try to make more voice of this backend. So we definitely want to try it. Yeah, and because new backend support is huge, so we will not support them all by our sides. We will make some of them become the LFX mentorship. So if you are interested to contribute, we will have the mentorship announcement soon. So you can apply that and contribute any backend you want, and to to join this inference library support plan. Yeah. So let's first part, this priority list is just from my mind. I just believe some of them is important, so I put the priority in this list. And I'm open to, if you believe some of them or other backend is more important and we should have it right now, please just, leave comment under this issue, so we will know that, and we'll try to, prioritize the workshop to, to finish it. Yeah, so, thanks. We already have some comments below. Yeah. So that's all of our, our initial plan, and this may change because, the LLM, change very fast, and we have no idea what will happen in the next week. Yeah. So that's all of my presentation. Thank you.
All right, thank you, Hydai. Yeah, so I think to support multiple backend is a critical part of our approach, because that allows the application developer to be decoupled from the person who runs or manages the application, right? So as an application developer, I only need to make sure the model runs on my machine. So say if the model runs on, I have a Mac, the model runs on the Mac Metal framework. That's good enough for me. I should be able to ship the software. Say in production, it may be NVIDIA, or maybe Intel, later generation Intel CPU only. The person who runs it should be able to make sure that WasmEdge is installed on that target machine with, say, the CUDA plugin. Or, when we have the Internet transformer library, the Intel transformer library plugin, right? And sorry, I have a little bit of cough today. So, that would allow the application is written and tested on my Mac, to be able to automatically take advantage of whatever hardware device is available on the target machine, right? That brings the Java-like developer experience, where the developer only care about the API and care about local testing, and the guy who's deploying it, the Kubernetes administrator or the cloud developer would have to make sure, would have the job with the responsibility to make sure that the right library is installed on their machine, so that the binary application that I develop, I distribute, would be able to run properly and efficiently on the target machine. But in order to achieve that, we really need to support as many target architecture behind the same common interface, which is WasmEdge interface. So that's essentially our whole idea behind the plugin system, and also, as Hydai has mentioned, one of the ways to abstract GPUs is through the web GPU effort, where it was initially to abstract GPUs for web browser use, right? And so, but it not only has a set of JavaScript APIs, it also has a C API in the .h file. So that allows us to write to that specification as well. And we are under discussion with some very large virtualization partners, where in their container infrastructure they would support web GPU, and I believe we could be one of the first runtimes to support web GPU in those ecosystems as well. So I'm really excited about that. That's where Hydai talked about the BurnRS library, which is the AI inference library based on web GPU. So yeah, that's obviously I'm super excited about all this work that is about to happen. And if you guys have ideas of how to prioritize this task, what should we support first, and or better yet, if you have time to make a contribution, we'd really appreciate that, and we'd love to see contributions from that direction as well. So even if not necessarily in the form of implementing code, but say testing the plugins that we already have, right? So that's something we'd love to see, and we will have the AIFX mentorships positions later this month, and also throughout the year for those implementation tasks. So if you know a good graduate student who's willing to take on those challenges, we'd love to hear from them as well. So DM4 and Hydai had talked about how to run inference models inside WasmEdge, and but that's only part of the story, because today we build AI applications. We not only need to run inference of the large language model, we also need to build the surrounding infrastructure, what people call the RAG infrastructure, the vector database, and things like that, to store external knowledge and add those contexts into the prompt, so that the model can provide relevant answers to the context, to the knowledge that we already have. And so on that front, I asked Sam to join us and talk about some of the latest work that he has done with AI agent and LangChain integration from WasmEdge point of view. So Sam.
Hello. Can you hear me?
Yes, and we can see your screen.
Okay. Okay. Wait a moment. Okay. Okay. Hello guys. Happy New Year. In the past December last month, we did some work to integrate our LLM infrastructure with LangChain. So in this part, I will share with you our considerations and the progress of this work. First, it's about motivation. According to our investigations on the LLM community, we got two observations. The first one is in the area of LLM, Python ecosystem is huge. Maybe you know, there are a lot of resources we can make use of to help us build LLM apps based on our infrastructure. For example, when we want to build up a chatbot app with a graphical user interface, we can use a Streamlit package to create a GUI front end. Use LangChain or Llama Index as an intermediate layer to interact with other third-party resources. And we can also use various utility packages to parse or analyze PDF or Office, Word, Excel documents, and more resources. And the second observation is that compared with the backends, I mean just existing backends integrated with LangChain, our infrastructure can provide developers a Wasm container environment to run inference tasks. Based on these two observations and considerations I mentioned above, we believe it's valuable to integrate our LLM infrastructure with LangChain. For Python developers, they can have a better choice for running inference tasks in a secure and a portable environment. For our community, developers can build up their own LLM apps based on our infrastructure much faster. So we create about 2 weeks ago, we launched a PR in LangChain. In this PR, we created a new integration named Wasm Chat, in which we introduced Wasm Chat service object as the first step of our plan. And in this picture, shows how Wasm Chat service object interacts with Llama API server. Suppose there's a user message, and this user message will be passed to API server, and then follows this path to the GGML backend. And the GGML backend will convert the message sequence, including, for example, system prompt or a system message or user message into a prompt string. And the prompt string and also other model parameters will be passed to WasmEdge runtime, where the WasmEdge interface. So in this picture, maybe you can see the Python code. Just 4 steps. Anyone can just create a Wasm Chat service instance and just prepared a message sequence and feed the message sequence to the instance, and then wait a moment. You will get the response, and after passing the response, you can get the generated message. Yeah, this is very easy. So now I will before demonstrate. Actually, we just before the demonstrate, I will give a short introduction about RAG. RAG is a technique for augmenting LLM knowledge with additional data. Usually, LLMs can reason about wide-ranging topics, but their knowledge is usually limited to the public data up to a specific point in time that they are trained on. If you want to build a AI applications that can reason about like private data or data introduced after a model's cutoff date, you need to augment the knowledge of the model with the specific information it needs. The process of bring the appropriate information and inserting it into the model prompt is known as RAG, short for Retrieval Augmented Generation. Okay, I put two pictures here, and this picture shows I mean, just RAG has two major components. This one is this picture presents the first component. It's indexing pipeline. Usually, we just when we just use RAG, usually we need to load data from a source like a PDF file, and then split the large documents into smaller chunks. After that, we compute the embeddings of each smaller chunk, and in the last step, we store and indexing the embeddings in storage. This picture shows the second component, retrieval and generation. Given a user input, the relevant splits are retrieved from the storage. And then a chat model or LLM generates an answer using a prompt that include the user question and also the retrieved data. Yeah, this is the two major components of a RAG. So now I will demonstrate a RAG chatbot, which is built with our LangChain integration and also our Llama API server. Okay, on the left side, you can see this is you can see it as a remote service running on a remote server like AWS, and you can see we will use Llama 2 13B chat model, and the version of Llama API server is 0.2.2. And this is the command to start the API server. Okay, the service will be served on this URL, and the port number is 8080. And on the right side, one thing, you can see it a remote service. Okay, on the right side is our RAG chatbot. You can see it. Actually, it runs locally, so it will interact with the API server where this. Okay, with this URL. So it's a Streamlit application. So it will open up a browser and render the UI in the web page. Okay. Okay. Let's see. Oh, okay. The first step we run our RAG chatbot is to specify the service URL. Here we just use a local host 8080 URL. So connect, and here RAG. Maybe you remember RAG chatbot requires a specific data source. So here I prepared a PDF paper, Bitcoin white paper. So just drag and drop here. It's loading the model. It's loading the PDF, and we can see the process here. Let's see. This information tells us. Okay. Okay. Here. This information tells us the PDF is loading and chunking. It's the first two steps of indexing, and this part just compute the embeddings of each smaller chunk and injecting the embeddings to the storage, a vector DB. This vector DB is used here in this app is Chroma DB. Okay, it's ready. So let's go back here. Let's ask a simple question. Okay, what's Bitcoin? So let's see how what's going on. Okay, entering new retrievable QA, and on the server side, maybe you can find just interesting things. There are two parts of information. This part is the okay. This part is our question, right? This part is the relevant retrieval data. So these two parts are combined into a single parameter string, and then the parameter string will be fed to the model, and the model will be after the inference computation, the model will be return the produced string. Yeah. Okay. This answer is beneficial. So actually, this page on this slide, maybe you can see the difference between RAG, the results returned by RAG chatbot and a common chatbot. I think I took the snapshot of RAG chatbot before the community meeting, and I found this result is better than I did before. And all these two parts are better than the result generated by a common Wasm bot. I think maybe you guys have interest in trying our Wasm RAG chatbot. It's powerful than a common chatbot, and also very interesting. You can do a lot of things, and more importantly, the data, the data from the PDF may be sensitive and also maybe private. So all this data just stored in local, not in server side. So it's I think it's better for anyone just care about their privacy. Okay. Next step, we will just focus on 3 key targets. The first one is in the current Wasm chat integration, we just provide a very simple and web service based integration Wasm chat service. And in the next step, we would like to provide a new object named Wasm chat local. It's it can run locally. So maybe just some users or developers are more interesting in this integration. The second target is to extend the RAG chatbot to support more file formats and also web pages. The last but the most important target is we are exploring multimodal applications because multimodal is I believe is the most it's the most popular topic in LLM community. So we will support multimodal in the future. That's all. Thank you, guys. Back to Michael.
All right. Thank you, Sam. Yeah, that's I think that's great. You know, the RAG application with Streamlit and LangChain, obviously, as Sam has demoed, has a lot of moving parts. So we intend to write all those up and have simple tutorials in the coming weeks so that you know, everyone can try it. And you know, that will allow us to use a large ecosystem of LangChain applications by simply swapping the OpenAI backend with the WasmEdge backend, right? You know, so now instead of paying for OpenAI and sending your data to OpenAI, you can just use it locally. And more interestingly, you can use any backends. You know, you can run it on, like I said, on Mac, on NVIDIA, on anything, right? You know, so one of the more interesting use cases of this is because WasmEdge is running as an API server, leveraging the WasmEdge large language model capabilities, but also the WasmEdge server socket capabilities. So that allows us to run WasmEdge on whatever machine that you have GPU. And then you have another machine that's the CPU-based machine where you can install LangChain and all this heavyweight Python stuff, and to serve up, to act as the intermediary for the RAG database and all that stuff, right? So, you know, I think there's just an infinite number of possibilities. And with open source large language models, especially cross-platform open source large language models in the mix, I think we are going to be able to do a lot more. You know, I'm obviously you know, very excited about that. And thank you, Sam. You know, so and we look forward to you know, having the entire community trying this out, you know, in the next couple of weeks. Okay. All right. So I think we are, we are running a little long for this. We started late. We are running a little long for this session, and but I do want to hang around for a couple of minutes in case you guys have questions, or you know how to reach us, offline as well. So that's yeah. If you have questions, you can ask now, or we can we can have a mistress guest speaker next month, who I promise will be good. So make sure you come back next week as well. Yeah. Thank you. So you can just speak, or you can type on the chat, whatever you want. Yeah, thanks. All right. So if there's no more questions, I think we are we can finish today. That's again, we have exciting programs that's lined up for at least the Q1 for this year, for the next 3 months. So make sure you come back to the community meeting, for February, March, and beyond. Thanks.